Hey all dear friends, this is Brajesh Chaudhary, your Quantum Guru. In this video, I am taking a very good question of kinematics from Pathfinder, in which a dog is chasing a cat. I don't like dogs and cats, so in place of dog, I am taking a cheetah, and in place of cat, I am taking a gazelle. So a cheetah is chasing a gazelle. So let me read the question. A cheetah running with a constant speed v is chasing a gazelle that is running with a constant velocity u vector. During the chase, the cheetah always heads towards the cat. At an instant, direction of motion of the cheetah makes an angle theta with that of the gazelle, and the distance between them is r. Find the magnitude of acceleration of the cheetah at this instant. So let's proceed to solve this question. So here this is a gazelle that is moving with a uniform velocity u vector along this line and is being chased by a cheetah. At the shown moment, the velocity vector of cheetah is v1 vector. Distance between them is r, and their velocities vector are making angle theta at this moment. It is moving, it is mean the gazelle is moving with a constant velocity always on this line, but this cheetah has to chase it, so it will always velocity will always be heading towards you, so it will have to continuously update its direction, something like that, so that it can chase the gazelle. So direction of the velocity of cheetah will change, but its magnitude is constant as it is given in the question. That magnitude is v. Now after a very small time, say dt, gazelle moves from here to here. The new direction of cheetah would be something like this. So now the new direction would be of the cheetah would be along this. So new velocity of cheetah is a v2 vector, and let me assume that this has changed by a very small amount angle d theta. During the interval, the gazelle moves a distance d theta, so that still gazelle, the direction of velocity of the cheetah is always heading towards the gazelle. Now v1 vector and v2 vector are constant in magnitude, but their direction are changing. So from here to here, the change in the velocity of the cheetah would be say dv vector. This is the change in the velocity. So this interval from here to here or from here to here is dt, time interval. So we can write the instantaneous acceleration of the cheetah is dv vector by dt, and the magnitude of acceleration, take a mod on both sides, so that is a mod a is equal to mod dv by dt, and the mod a is, let me just write a, that is the acceleration of the cheetah. That's what we have to find, and I can write this is the mod dv divided by dt. So you can find the mod dv. There is a direct formula also, or you can use the cosine rule. So see, you can see that the angle between v1 vector and v2 vector is d theta, and the difference is dv. So using the cosine rule, I can write the magnitude of dv. Before that, v1 vector and v2 vector have the magnitude v, and now the magnitude of the change of the velocity of the cheetah during that time interval dt, that dv vector magnitude is the square root of v1 square plus v2 square minus 2v1 v2 cosine of the angle between them, that is a d theta. So it is a v1 square plus v2 square minus 2v1 v2 cos d theta. So put v1 v2 as a v, so that will become 2v square minus 2v square into cos d theta. We can take 2v square common, so that will become square root of 2v square into 1 minus cos d theta, like this. And then I can further make this trigonometric identity use. So 1 minus cos theta is 2 sin square theta by 2. So 1 minus cos d theta is 2 sin square d theta by 2. And now you can take it outside the square root, so that will become 2v sin d theta by 2. And we can use the approximation. If the theta is very small and measured in radian, then sin theta is theta. So sin d theta by 2 will become d theta, and that 2 and 2 will get cancelled. So the magnitude of this change in velocity from here to here, dv vector is equal to v d theta. Now put it here. That dv vector magnitude. So we'll get that v d theta into divide by dt. And now So what I want to do, I want to just make a perpendicular from here to here, and let me write, suppose the magnitude of that length is say dr, and that is a kind of we can think of that arc length from here to here of the circle r. So dr, because d theta is very small, so that chord length is approximately equal to arc length. So dr can be approximated to r d theta. This is r and this is d theta, and here you can see this is theta, and this angle is very small. This angle is very small, so this angle is also approximately theta. So this is theta, this is perpendicular, this is ds, this is dr. So we can write dr as also ds sine theta. Once again, this d theta is very small, so this angle is approximately theta. So dr is equal to ds sine theta. So that also can be written as a ds sine theta. ds is the distance travel or the displacement of the gazelle in time dt, and it is moving with the uniform velocity u, so ds will be u dt. So u, that is a u dt sine theta. So now from here, this equation and this equation, I can write d theta by dt as a u sine theta by r. D theta by dt is u sine theta by r. Just put this value of d theta by dt into this equation 1. So we'll get a is equal to u into v sine theta by r, and that's what the